Hey everyone, welcome back to the channel. Have you ever looked up at the night sky, seen all those twinkling stars, and wondered, what if we could live out there? Earth is amazing, our one and only home, but what if we had to find another one? It sounds like science fiction, but scientists and dreamers are already thinking about this. So today, let us embark on an epic journey to explore our potential future homes in the vast expanse of space. Where could humanity go next? First stop, our closest celestial neighbor, the Moon. It's right there, a 3-day trip away. We've been there before, so we know we can do it. Building a base on the Moon has some real advantages. Its low gravity would make construction easier, and we could mine its surface for resources like helium-3, a potential fuel for future fusion reactors. Plus, the Moon's far side is always shielded from Earth's radio noise, making it the perfect spot for a giant radio telescope to listen to the cosmos. But living on the Moon isn't a walk in the park. It has no atmosphere, which means no protection from solar radiation or micrometeorites. The temperature swings are extreme, from boiling hot to freezing cold. And that fine, abrasive lunar dust could be a serious health hazard and wreak havoc on equipment. A lunar colony would have to be built underground or inside heavily shielded domes. It would be a challenging start, but a stepping stone to the rest of the solar system. Alright, let's travel a bit further out to the red planet, Mars. Mars has captured our imagination for centuries. It's the most Earth-like planet in our solar system. A day on Mars is just a little longer than ours, about 24.6 hours. It has polar ice caps, which means there's frozen water we could potentially use. The soil, or regolith, could be used to grow crops in controlled environments, and the atmosphere, while thin, offers some protection from radiation. Companies like SpaceX are dead set on getting humans there, with Elon Musk dreaming of a self-sustaining city. But the challenges are immense. The journey alone takes 6 to 9 months, exposing astronauts to cosmic radiation. Mars is incredibly cold, with an average temperature of -80 degrees Fahrenheit. Its thin atmosphere is mostly carbon dioxide, so we can't breathe it. We'd have to live in pressurized habitats and wear spacesuits anytime we go outside. And then there's the dust. Martian dust storms can engulf the entire planet for weeks. Terraforming Mars, engineering its climate and atmosphere to be more Earth-like, is a concept that excites many, but it would be a project spanning centuries, if not millennia. Still, Mars remains our most promising candidate for a second home. What if we looked beyond rocky planets? Let's get a little creative and head to the outer solar system, to the moons of Jupiter and Saturn. Take Europa, one of Jupiter's Galilean moons. On the surface, it's a ball of ice. But beneath that icy crust, scientists believe there's a vast, salty ocean of liquid water kept warm by the tidal forces from Jupiter's immense gravity. Where there's water, there could be life. And if we could build a base there, we'd have a nearly unlimited supply of water. The challenge: drilling through miles of solid ice to reach that ocean, all while dealing with Jupiter's intense radiation belts. It's a daunting task. Then there's Titan, Saturn's largest moon. Titan is fascinating. It's the only moon in our solar system with a thick, dense atmosphere, even thicker than Earth's. It has weather, clouds, rain, rivers, lakes, and seas. The catch: it's not water, it's liquid methane and ethane. The temperature is a frigid -290 degrees Fahrenheit. But that thick atmosphere offers great protection from radiation. The surface pressure is also similar to Earth's, so you wouldn't need a heavy, pressurized suit, just a very, very warm one and an oxygen mask. You could even theoretically fly by flapping wings attached to your arms in its low gravity and thick air. The building blocks of life are abundant on Titan, and it could be a resource-rich world for future human settlers. It's a strange, alien world, but one with incredible potential. Now, let's think even bigger. What if we could build our own homes in space? I'm talking about massive, rotating space stations called O'Neill cylinders. These were proposed in the 1970s by physicist Gerard K. O'Neill. Imagine two giant cylinders, miles long and miles wide, rotating in space. The rotation would create artificial gravity through centrifugal force, so you could walk around just like you do on Earth. The inside surface would be our living space with land, water, trees, and cities. Huge windows and mirrors would direct sunlight inside, creating a day and night cycle. You could have parks, farms, and entire ecosystems, all inside a self-contained world. We could build these using materials mined from the moon or asteroids. The advantage is that we could design our perfect environment from scratch. No extreme temperatures, no hostile atmospheres. The technological hurdle is, of course, enormous. Building something on this scale would be the biggest engineering project in human history. But it offers a vision of a future where we don't just adapt to another world, we create our own. So, we've explored our solar system, but what about beyond? Our sun is just one of billions of stars in the Milky Way galaxy. And many of those stars have planets of their own called exoplanets. Since the 1990s, we've discovered thousands of them. Some are super-Earths, rocky planets bigger than our own. Some are in the habitable zone of their star, the region where temperatures are just right for liquid water to exist on the surface. For example, the TRAPPIST-1 system, about 40 light-years away, has 7 Earth-sized planets, with several of them in the habitable zone. Finding an Earth 2.0 is the ultimate prize. The problem is distance. Even 40 light-years is an unimaginably vast distance. With our current technology, it would take us hundreds of thousands of years to get there. To make interstellar travel possible, we'd need revolutionary new technologies like fusion-powered rockets, solar sails pushed by powerful lasers, or maybe even warping spacetime like in Star Trek. These are purely theoretical right now, but who knows what the future holds? If we could overcome the travel time, we might find a new world that's even better than Earth. So, where does that leave us? The Moon, Mars, the moons of the outer planets, giant space habitats, or a distant exoplanet. Each option presents its own set of mind-boggling challenges and incredible opportunities. The truth is, there's no easy answer. Any move off-world will be the most difficult and ambitious thing humanity has ever attempted. It will require global cooperation, technological leaps we can barely imagine, and a pioneering spirit that pushes us to explore the unknown. But the quest for a new home is more than just a survival plan. It's about our inherent curiosity, our desire to explore, and our drive to understand our place in the universe. It forces us to innovate and to dream bigger. For now, our top priority must be to protect our beautiful, fragile Earth. It's the only home we have, and it's perfectly suited for us. But looking to the stars and planning for the future is what makes us human. It ensures that no matter what happens, the story of humanity will continue, written among the stars. What do you think? Where should we go first? Let me know your thoughts in the comments below. Thanks for watching, and if you enjoyed this journey through the cosmos, don't forget to like, subscribe, and hit that notification bell for more adventures. See you next time!